Okay, today we're going to be measuring and drawing angles before we lead into bearings that we're going to find with using a protractor. So, the equipment that you would need, I prefer if you use a pencil. Try to have yourself a nice sharp tip. Protractor. Because we're going to be measuring some angles that hit reflex angles, it's often really good to have this circular one. However, if you do not have it, I'll try to show you as best I can on what you can do to use this. And when you're back into class, the normal protractor, and when you're back into class, we can go through any other ways in which you can best use it. So let's look at measuring some angles. The first angle we're going to measure here is it says to use a protractor to find the size of the angle. So when measuring, some people call this the T, some people call it the hash marks, some people call it the point. As long as you know what you feel comfortable, the vocabulary you feel comfortable with, and also knowing what possibly might be given to you in a exam. So I'll take this point, make sure it's lined up. Hopefully you can see this nice and clearly through the camera. Make sure this line is also accurately lined up on as well. So hash point, I'll call that the zero line or baseline. Am I comfortable? Am I happy? Yes. And this gives me an angle. This is this inside angle here. That inside angle was at 40 degrees. I'll show you again. Point to the vertex. Making sure this zero line or baseline is accurately measured up, lined up. And if I look at this line here, just make sure, always double check just to make sure you've got it right. It's not too difficult, so you just want to be accurate. You go to the point, you see that this is lined up at 40 degrees. When we write that, I would say that this angle is 0.40 degrees. Make sure your penmanship is great. 0.40 degrees. We want to write it in 3 digits. 0.40 degrees. Same thing as 40 degrees. Let's look at one further angle. So we can see that we're looking for the inside of this angle, which is a acute angle. So we know that an acute angle is going to be less than 90 degrees. We can already look at this angle and see that it's an obtuse angle, given the fact that it's greater than that is greater than 90, but less than 180 degrees. So we know this is an obtuse angle. Acute angle, obtuse angle. Next we'll look at a reflex angle, which is because this shows you exactly what I was looking for, the outside of this angle. So it's asking for a reflex angle, which we know is greater than 180 degrees, but less than 360 degrees. So let's look at measuring this angle. This interior angle here gives me an obtuse angle. So again, taking this hash mark or T, putting it directly on the vertex. We want to be accurate as possible. For those of you that will need a scribe, you need to be able to tell the person that's scribing for you exactly how you want the protractor to be laid out. So this looks about right. Zero line or baseline sorted. The T is right on the hash mark, the vertex. If I look at this line, it looks like what I often also do is take a point, or I'll extend this line to make a point, just in case you can't read it. I don't want to write on the textbook, so do forgive me. I normally could take this line to extend it so it goes beyond, so when I go back to read it, that line will go past. So I'll show you what I mean, ladies and gentlemen. I'll draw the line as lightly as possible, so that way I can erase it because this is one of our texts. Now, again, hash mark or T to the vertex, making sure my base is, my zero line is directly lined up. And if I look here, it goes nicely onto right on the middle at 135 degrees. Why do I know it's at 135? Because if I look at this, it definitely cannot be between, it can't be 55 because it's greater than 100, is it greater than 90-degree angle, so it's an obtuse angle. So I look at this interior angle and it says 135, okay? So I will write that as 135 degrees. So now we're going to look at measuring this angle. We can see that it's a reflex angle because it's asking for this exterior angle. So we know that this is 180 if it's a straight line. So we're going to find what the rest of it is. We can look at this and say, it's going to be right around 300 or so. So let's go make sure. So when we look at measuring this angle, first of all, let's look if we can extend this angle first and foremost. Try to do this accurately as possible. It's always best to measure twice, cut once. I know in this instance we're actually drawing a line, but if you ever speak to any carpenter or any builder, measure twice, cut once. I'm very happy with that line. So let's look to take the measurement. So this circular one, you see we have our 180 line, our hash mark, and our 0 line. Let's measure those off. And if you look at this angle, because I extended the line previously, you can see it crosses right through. Yeah, it crosses right through where it says 340. So this angle is 340 degrees. In case you ever get into an exam or some sort of situation where you don't have a circular one, you want to also be able to use this. Therefore, what I'll find is I know that, again, this is a reflex angle. So I measure my hash mark. I'll actually do it this way. I'll mark this off. And I can see this says 160, but I'm looking at that angle right there. It says 20. So what I'm going to do, the reason I'm using that, because I know it's going to be past the 160. So if this we know is 120, and I know this gets slightly more complicated, and that the remainder of that angle gives me 20, then I can be certain to say, if I subtract that 20 degrees from my 360, I should know what this angle is. If I take 20 from 360, I get 340. And as you saw before, we have 340 degree angle. So again, it's another way of using this. Again, when you get back into class, we can look at different ways in which we can use this instrument, because we don't always have instruments such as this. And then this was the same thing will apply when we do other things in life, like using a compass. We could talk about how these come to, how we can apply these tools and tactics. All right, guys. Okay, ladies and gentlemen, now we're going to look at drawing angles. The first angle that's being asked of is to make a 30-degree angle. I always find it best, make the vertex. After you make the vertex, make your line or your baseline, whichever line you wish to call it. So then, at this point, I'm going to put, again, the T or the hash mark line up with that vertex. I'm happy that I've got that correct. I'm not happy that I have this 0 line on the same line that I've drawn the original line. So let's make sure we got that right as well. Again, measure twice, draw once. At this point, I'm looking for 30 degrees, which is right here. We know it should be an acute angle. So now, vertex, that's the opposite side of the line. I'm going to connect the vertex to the line at a turn of 30 degrees. So bring these two together, and then I'm going to say that this angle is a value of, or a turn of 30 degrees. The next angle they're asking us for is for a turn of 125 degrees. Already, we're going past 90 degrees, so we know that it's going to be an obtuse angle. Again, make your vertex. You see me using this straight edge. You could just as easily use a ruler, but any straight edge would do. And being that you have this, why not use it? So let's make this angle. It's important that we use a straight edge. Any straight edge will do. And make sure I have this T or this hash mark lined up with my vertex. I'm going to make sure that this line here, this baseline or zero line, is lined up to this line, my original line. Okay, with that, I am happy. So, if I look at this, if I look at that, that says 120 there. You should know that that just doesn't make sense, because if I draw a line like that, it's going to be at an acute angle, which makes it that 60 would make it 60 degrees, to make it an acute angle. At this point, we're looking at this outer line. And if I want to get to 100, the inner line. So I want to make it to 120, I'm going to go right here. Now, for the sake of argument, I'm not going to go through the other angle. I'm just going to measure it up. So I don't have to go all the way to the top of the page. As long as I show that the angle is correct. Let's again measure twice, mark once. I see that this line is lined up, but I don't want to cut through my previous drawing. So I'm just going to stop right there. Okay? So now, this is the turn that we're measuring, which gives us 120 degrees. The next angle they're going to ask us for is a 90-degree angle. And so you can easily identify them. And so whether you make the original line going this way or that way, you're going to get a 90-degree angle. Well, let's just do it for the sake of doing it, making sure that we have it accurately measured. Our vertex, I'll make the line going this way first. It's important that we have straight, accurate lines. So if I had made that on a bit of a slant, then this angle would have to be a bit more of a slant. Make sure I got it lined up. Make sure this is I'm happy with that. And so that's my vertex to make the 90-degree angle. And then I connect to bring them together. Line, measure twice, cut once, or line once. What makes this slightly different from any other angle, you will always notice this. If you see that, you don't have to actually put any number, because that tells me it's a 90-degree angle. So we know that this is 090 degrees. The final angle we're going to look is a turn of 212 degrees. So again, pretty much all starts the same. We make vertex, create a line, vertex, and now we're going to measure. We're going to use this instrument now. We're going to measure 212 degrees, making sure every line, this is lined up. And we'll get to 212. Hopefully you can see this nice and clearly. So it gets us 210. That says 220, 210. This says 200. So we know it's going to be, if I count back, that's 210, 211, 212. And then I quite simply take the line So I take the two vertex, line them up. So it's asking us for, and if you look at that, if this was 180 degrees, it would go straight across. However, it goes slightly down, so it's just beyond 212, and we're talking about this angle, which is a reflex angle. And this gives me a turn of 212. You're probably saying to yourself, why does he keep on saying turn? Degrees measure turn. So that's why you heard me referring to this as a turn. So degrees measure turn. So this is a turn of 212 degrees. So we're going to be doing some work on measuring and drawing angles before we lead into bearings, which will be our very next section. When we measure bearings, we need certain pieces of equipment. Firstly, we'll need a protractor. Quite often you can use a ruler, but you would also find if you have a protractor, you can use this straight edge as your ruler as well. What I want you to be familiar with is this protractor. This is the protractor we will use often in school. It may not show up as well on the on this film. However, when you get it in school and we practice together, you will see just how beneficial this could be. But for the sake of this film, and this is going to be as clear as I can get it and as large as I can get it for you to be able to see well, we're going to use this for today. When you get back into school, again, we will use this protractor instead. Or whichever one you feel most comfortable with, I should say. Now, that's equipment. Also, I prefer to use a pencil, just in case there's any error or mistake. I know that often the GCSE tests and any other exams, they often ask you to use a blue or black ink pen. However, this will often be accepted when doing bearings to show your working. So there are three things that you need to be aware of when you're finding the bearings. The first thing is always look to measure from north or due north. The second thing, you always want to measure working clockwise. The third thing is when you're giving out the measurement of a bearing, you may find it in degrees, or we may find it in degrees, but you would always have it in 3 digits. So sometimes if we have something that's in, let's say for example, 170 degrees, we have 170, which gives you 3 digits. But if the bearing was 22 degrees, you want to have a 022. So you always have three digits. Let's just look at the example of finding the bearing from Southport to Lancaster. From Southport to Lancaster. When I go through this, think about the 3 steps that we always must do, as I'm going to show you just now. So, firstly, we want to make sure the point that's given to us is always measured up directly with this center point of the protractor. When it talks about going to due north, or when I give you the idea of going to due north, I want to put this center point directly onto this point. I feel like I've got it measured up, but I also want to make sure that this due north line, that's from 0, hopefully you can see that. See 0 here, 0 here. So we're going from the outside and the inside. However, we're going to look at just doing the outside for now. I measure up that center point with this point that's given to us. Very often, they do not give you that north point. So sometimes you have to actually go in and draw the due north. So I'll measure this up, and make sure my line is matched up. Sorry, my due north line is also matched up on that 0 line. Now that I'm feeling 100% sure that this point and my line going due north are lined up correctly, I'll go from due north, going clockwise to find my bearing. I'll come around, you may see 10, 20, 30, that looks like 35, but if you come back maybe 1, 2, maybe about 3 spaces, it looks like it's around say 37. So I'll mark this point or this bearing at 37 degrees, but if I had to write down on an exam, I'll write 0, 3, 7. From Southport to Lancaster gives me a bearing of 0, 3, 7. This GCSE test sample asks us to, it says this is a diagram, shows 2 points, A and B on a map. Basically what they're going to ask us to do is find the bearing from B, of B from A. That's some very key information. It tells you where you're coming from. So if you're coming from A to B, so it says find the bearing of B from A. So it means we're starting from A going to B. What I always find very helpful, and you will always find this is very helpful, is then, as I told you previously, you want to make that line to make sure that you have from your center points lined up. So we're going from A to B. Find the bearing of B from A. So you always understand where you're coming from. From is A. From that point, again, we want to make sure we at this point lined up directly with this center point. Again, we want to make sure that we have it facing due north. So we have the center point. Make sure we have line. You see how this line here is not lined up? My 0 point or my due north needs to be lined up. Now that I'm happy with that, I can see now this one's inside. So you will, like I said to you before, a lot of times we have to make that line a bit longer so that we can see it. So I'm going to take the protractor up and just extend that line. And that's not the reason why we want to use a pencil. In case I need to erase this line, I'm going to go from center point to center point. And I'm making this line longer so that I can read it on the opposite side of the protractor. That line is still true. So bring it back to protractor, line up my center point to that point, making sure that this line is lined up due north. And again, I'm going to read it clockwise. As you know, the clock, when it ticks, it goes this way. So we're going from clockwise, line up our protractor accurately. And now I have the line on the outside so I can read it that much better. So I'm just double checking, making sure it's accurately lined up. And it looks like it's going from 0, 10, 20. Looks like it's right smack directly on 25 degrees. So this bearing, if I have to write it on the test, it's going to say 0 to 5 degrees. That's what we're going to practice for. A few things for this week. We're going to extend a bit further past this, but we're going to try have a go at these simple ones for now. Okay, thank you very kindly, and hopefully you have a lot of success.